Hello, and welcome everyone to another eVision Tech Talks. Our today topic will be surface inspection. First presentation for today will be done by Robin Zirkler from Chromasens and Christophe Chaudy from Euresys. And Robin will make the first part of the presentation, which will be divided in two parts. One about cameras, one about software. And now I'm waiting for Robin.
Okay. Yeah.
Here he is.
Okay, now I will share my screen.
I will tell you, it's perfect. It's in presenting mode.
Okay, very good. Yeah, hello and welcome. Today, my colleague Christophe and I, Robin from Chromasens, we will present you the topic of advanced surface inspection for battery, paper, film, or glass inspection. So, Euresys and also Chromasens are a part of the TKH Vision group, which is a global group of machine vision technology leaders providing 2D and 3D vision components and solutions. So our agenda for today, I will start with the line scan acquisition for advanced surface inspection, and then Christophe will continue with using Euresys EasySpotDetector for surface defect detection. So a short overview about the company. So Chromasens is founded in 2004. We are about 90 employees here in Germany. We are a member of the TKH group since 2018. Our product portfolio are high-end or high-performance line scan cameras, image capturing systems for 2D and 3D, and also LED light technologies. We are also providing fully customized vision solution systems. So today, the topic is here advanced line scan acquisition for surface inspection. Before I start, I want to make a short introduction about area cameras and line scan cameras. So area camera, like you have it in your smartphone, where a single shot acquires the whole image. It's easy to get started, to get the first images. It's easy to align an area camera. So the cons are you have a blur on a moving objects, high costs for high resolution because of the sensor, and the 2D reflection geometry. So line scan cameras, the pros are we can have an endless acquisition on moving web. Short integration time reduces the motion blur. For high resolution is available at affordable costs. And the cons are the control of the relative movement is required. A precise synchronization of the movement is also required. And it's always challenging to align and configure line scan cameras. So what are typical use cases for line scan cameras? On one side, we have the continuous moving materials like web inspection, so roll-to-roll, print inspection, inkjet print, or optical sorting. And we also have the high-resolution application and lightning architectures like PCB inspection, wafer macro defect inspection, archiving, print inspection, or inkjet print like color profiling or nozzle detection. So surface inspections, what are the advantages of line scan camera? We have a large field of views, like for battery foil inspection up to 612 millimeters, or foil and surface inspection up to 680 millimeter. So we have a high resolution line scan cameras with a large field of view. We also have a high resolution up to 8 micrometers in a field of view of 673 millimeters. This is possible with multiple cameras in a RAW which are aligned. So not only the camera, we're also providing line scan lights. Different materials and different defects requires different type of lights to make them visible, and complex defects require sometimes more than only one light geometry. Here's some examples. On the left side, you can see a comparison between this stretch of a dark field and a bright field illumination. You can see it in the bright field. And on the right side, you can see the dents, which are only visible in the dark field light geometry and not in the bright field light geometry. So what are some typical light geometries? Here you can see we have a dark field geometry, light geometry, coaxial, bright field, backlight, or dome light. And we can also have some combination of a dark field and a bright field, or a dark field and a backlight, or a combined tube light, where we combine a tube, a dark field, and a bright field light. So today, I want to present the solution for battery foil inspection. We have 3 all-pixel EVO 8K co-express cameras. The light are 2, it's a combination of bright field and dark field. And we have a frame grabber, which is the Euresys Quarks Link Butt CXP12. So we are following a platform approach. Here we have the Vision Solution Platform, 3 all-pixel EVOs with a resolution of 25.5 micrometers, a field of view of 612 millimeters, a maximum speed of 2,295 millimeters per second. Here you can see the CAD model like it is in the CAD. Here, this is the real application. You can see the all-pixel EVO cameras, the bright field, the dark field, and on the bottom, the battery foil. So we have a special feature, we call it multi-field imaging, which allows us to scan a surface or object in one pass with 2 different illuminations. Here it's shown, you can see the camera, you can see the dark field illumination and the bright field. And on the bottom, you can see the battery foil. This multi-field imaging allows us to flash or alternating the light line synchronous, which is mentioned that we start with acquiring the line 1 with a bright field illumination, then line 2 with a dark field illumination, and then in the next line, we continue with the bright field illumination. So we are capturing an object with 2 different light geometry in one pass. And with the features from Euresys, from the Quarks Best Frame Grabber, we can deinterlace this image, which is at the moment interleaved. Now I want to deinterlace the image into 2 separate images. This is done on the frame grabber in real time, no GPU or CPU resources are needed. So you can see in this example, the bright field image and the dark field image in one pass. And this is the summary for advanced line scan, acquisition and frame grabber technology. We have a high resolution line scan, so up to 2,295 millimeters per second, at a field of view of 612 millimeters with a resolution of 25 micrometers. The multi-field imaging approach allows us to acquire 2 perfect aligned images out of 2 different lights in one pass. We have a perfect synchronization between camera, light, and transport speed. The deinterlacing is running on a frame grabber, so no GPU or CPU resources are needed, and we have a real-time processing on frame grabber. The usability, it's easy to set up. You can reduce the setup time. We have a perfect interaction between frame grabber and camera, and we also provide a flat field correction in the camera, which is independent for each light. And now my colleague Christophe from Euresys will continue.
Thank you, Robin. Okay. Do you see my screen? Not yet. There we go.
It's perfect.
Okay, so I will talk about the software part of the surface inspection, and specifically about the EasySpotDetector library from Euresys. A brief introduction about Euresys. It's founded more than 30 years ago, approximately 98 employees around the world. And we joined the TKH group 2 years ago. And Euresys is a manufacturer of components for machine vision, more specifically frame grabbers, like Robin talked about a little bit, FPGA IP core, and image processing software. And that's the part for today. So first, what is the purpose of EasySpotDetector? If you want to make segmentation of objects using Open eVision, so Open eVision is the set of software libraries for Euresys, you can use the simple easy object libraries. It will perform simple global segmentation of objects. It's really fast, efficient, but only work on uniform background and high contrast image. On the other hand, you can also use EasySegment, which is a deep learning based segmentation libraries. But like all stuff, it requires, of course, training. So you have to train on your specific context. And it can be slow if you would like to do segmentation of small objects on large images. With EasySpotDetector, we try to combine both worlds. So to have segmentation using conventional and efficient and fast approach, then use deep learning classification to confirm the defect or perform more specific classification. It has to work, it must work also well on a non-uniform surface with a texture background or noise. So EasySpotDetector is one library of the Open eVision set. It's a tool really dedicated to the surface inspection to detect defects like spots, particles, scratches. So with EasySpotDetector, you can detect this kind of contamination even in noisy images. It has been especially optimized to be really efficient and fast for inline production, inline inspection. It is compatible with line scan camera and also area scan camera. There is an optional pre-alignment function in EasySpotDetector that allows the detection of the position of the part inside the image. And there is an optional deep learning classification. It's optional in the function, but when you buy EasySpotDetector, you get everything. It just, you can skip one or the other step. This library is available for C++, C#, and Python application. So how it works in general. So first, from the camera image, we can perform here the alignment of the region of interest. So it's searching in the image, where are your parts? Then the detection of the defect itself happens here. You choose the defect by setting attributes. What is the type? What is the polarity? Polarity means, is it black over white or white over black? The size and the sensitivity of the detection. This step allows you to detect spots and scratches using conventional processing. This part is really fast. At that point, you get a list of detection or a list of candidates. For some application, it ends up here. You get what you are searching for. But you can push this detection, this segmentation, to a deep learning classifier that has been trained specifically on for that specific end industry. I will illustrate that later. So here I would like to talk about a little bit about the usage, the use case, the carbon-coated copper foil inspection the Robin talked about. So typically, it's very important in that context to detect scratches, small hole, foreign particle on this foil for security reason. Spot detector could be used on single shot picture. So when there is you submit the whole picture to the spot detector, or a line scan acquisition where you submit a feed of line. And as an indication of the processing speed, on the low-end processor, you can process up to 200 megapixels per second without a GPU. Some illustration here of the defect detection on the Chromasens images. So you get the detection of the defect you're searching for, and you get a fairly detailed and precise segmentation maps also. These images are not too challenging, but I have more example here. For example, that's carbon-coated copper foil. That's, I think, a 24 megapixel image, and there is a small black dot in the middle of the foil here. So that's typically what EasySpotDetector is good at. So detecting small and faint defect in large and noisy images. This is another view of the same context. So with a lot of black particles inside a noisy background. Here, there is some faint shadow-like defect that can be detected also with EasySpotDetector. And finally, another kind of defect, which is common, it's called scratches here. So it's the dark line in the middle of the foil. This kind of defect is detected also with the library and the particle too. So why a deep learning classification? So in surface inspection, usually the final decision really depends on the industry. So classifying defect or evaluating the severity of the defect is really specific to industry. It's not the same in battery that in glass inspection or plastic inspection or other context. So we think to have custom trained classifier that runs after the first detection is a good way to specialize the library for specific industry. So after the detection of the candidates, they are submitted to a deep learning classifier. That classifier is trained by the user. We have a tool dedicated for that. It's called Deep Learning Studio that allows the user to annotate, train, and evaluate the model. Then the model will be used by EasySpotDetector and can classify the candidates. There is very various way of using deep learning here. For example, to confirm or reject the detection, or to evaluate the severity of the detection, or simply to classify the detection between a different kind of defects. There is 3 other examples on different industry, the coated coil defect, film inspection, and glass inspection. So to summarize a little bit the presentation, EasySpotDetector is a single API and single license for 3 different functions: alignment of the region of interest to find where the part is in the image, detection of the defect, could be particles, spots, scratches, and then classification of the defect with a custom trained deep learning classifier. It has been made for fast processing, so it's really ready to use for inline inspection context. The library itself is compatible with C++, Python, and .NET software application. EasySpotDetector runs on Windows and Linux, including embedded systems, so on Intel and ARM platform with or without GPU. Of course, the GPU can be used to speed up the inference. Okay, oh, thank you.
So, thank you very much. And as we have less time, but a lot of questions, it would be great if Christophe, if Robin also could put on his camera. First question, can the Euresys Quarks Express deinterlacing be done with more than 2 light setups, maybe 3 or 4 lights?
Yes, this is possible.
This was a very short.
Yeah. So,
great. For the EasySpotDetector, is the bandwidth for the whole process, including the AI part, and what is the bandwidth for the whole process, including the AI part, and what bandwidth would be possible if only the detection for the candidates would be done and no AI.
Okay, if I understand correctly the question, so the bandwidth, if in terms of number of pixels per second process, is on a low-end CPU, so on Intel Core i7, I think it's around 200 megapixels per second without the inference. I don't know if it answers the question. The inference itself is made by a GPU if you have one in parallel, so you can do the stuff in different thread. But after that, yeah, it really depends on the application also, and of course the hardware configuration. I don't know if I understand completely the question, actually.
Otherwise, the person could repeat his question or specify which information he needs. But yes, it answered the question.
Okay, thanks.
And we've got, I think, time for one more. Both persons will be at our final Q&A, so I think we can't answer all the questions now, but Euresys mentioned the processing without GPU. What about if a customer uses a GPU and has larger data that cannot be handled by the CPU? Good question, I see.
Yeah. Larger data that cannot handle by the CPU. I don't understand completely the questions. So the CPU will handle the detection itself. So it will process the image line by line and then produce candidates. It can produce really, really big picture. And then only the small detection will be submitted to the GPU. So usually the GPU is not a problem here. Is about something that are directly into the GPU bypassing the CPU. Okay. So with EasySpotDetector, if it's the same question, it's not possible to bypass the CPU at that time. So you have to go through the CPU for the first alignment and extraction of the candidates, then send the detected candidates to the GPU.
Okay, thanks. Your answer question. So, Christophe, Robin, thank you for the presentation.
You're welcome.
Question to TKH Vision. Is there a shift between the two images from the multi-field imaging approach? And if not, why?
The two images are perfectly aligned, so they are really line precise. So we have this multi-field approach where we are flashing the different illumination, and the line shift or the spatial correction is done on camera side on FPGA. So really you get the line synchronous, two images, they are perfectly aligned.
So I think we're coming to an end. A lot of information for today. So thank you very much for the great presentations. Thank you very much for the audience for listening to us. And I would say bye. Hope to see you maybe next week for Robot Vision or at the Vision Days at the beginning of December. Bye.